Hello, folks. I'll get moving in a little bit. Imagine some more people are going to stream in here in a minute. But yeah, you can always feel free if you got any questions now. If there's stuff you want to ask me, go right ahead. I'll get started in earnest in another couple minutes. Just give people a run through of starting one of these again. See, now I didn't update the links on the website. I should grab that lecture video and do that. Let's see. Let's see. Would have been 7th, I think. Yeah. Yeah. Okay, I'll update that. Okay, so see, we got a fair number of folks in. I'll go ahead and get started here, and I can always backtrack if anybody else needs any questions from early on. So just to give folks a reminder, we already had to make one of these, our markdown documents, as a homework, but we'll just start a fresh one here again, just to walk you through the process in case you need a little refresher. I'm going to go ahead and go up to our markdown. Going to leave it on pretty much all of its defaults here. HTML, leave it for my default author. I call this homework 2. Okay. Going to go ahead and save this. Let's go lab 2. And wipe everything that's already there. And use this as a basis for what we're going to do. So create a new chunk here. Okay. So if you're getting started on this, you know you need to do some visualization of the Gapminder data set. How would I normally begin this R Markdown document, given that's what I want to do? Does anybody have any suggestions?
Make sure you have the packages that you want.
Yeah, sounds good to me. What packages should I have loaded? What are we going to be using?
Plot, ggplot.
Yeah. Okay, we're going to want ggplot. What else do we want?
Tidyverse.
Yeah, we could do that. That's an alternative. So if I just do tidyverse, that will load ggplot. It'll also load dplyr. It'll also load a lot of the stuff we'll use in the class. So that's another way we could do it. So you could specifically load tidyverse, or you could do like library ggplot, library, not library, library dplyr. But if I just load tidyverse, it's going to go ahead and it's going to load by default, doing library tidyverse will load ggplot and dplyr, but it'll also load packages like reader for reading in data, tidier for pivoting data, tibble is tidyverse data frames, per for doing iterative operations, stringer for working with text data, and forcats for working with factors. You're going to get introduced to every single one of these packages here directly, except per and tibble. Tibble will always be running behind the scenes, and per I don't teach in this class because it's basically just a way to build on top of apply functions, which you will there. Okay, so if I've loaded tidyverse, I load all that. What else do I need to load as a package? There's one key one I need, right? Where am I getting my data?
The Gapminder package.
Yeah. To get my data, I'm going to need Gapminder too. Now that I've got tidyverse and Gapminder, I've got basically everything we need to do. So in chat, somebody asks about set the right working directory to save plots. The thing is actually, in a WAR Markdown document, you don't want to mess with the working directory. Typically speaking, you don't want to touch working directories in your Markdown doc. It'll take care of it. So if I go get WD, the get WD that you're going to get inside your Markdown document is going to be wherever your Markdown document already is. So I don't have to mess with it in any way. If I want to be saving images specifically to a directory, I would, when I save those images, specify the directory I want them to go to typically, rather than do any kind of shenanigans messing with it directly. Okay, so we got some packages loaded. We're basically ready to go, right? So what I would normally do here is I don't want these messages like this, all this stuff here, to appear in my R Markdown document. How might I make it so when I knit this thing, those don't show? And so as an example, I'll knit this document here, and I'll see something like this. When you load tidyverse, it's going to display all that stuff right here in my Markdown document. I don't want to see that. How might I get rid of that?
We would use chunk options, echo, and include both set to false.
Okay, so echo equals false would hide the display of the code itself, but leave the messages. Include equals false, as you suggested. I don't actually need echo equals false if I have include equals false. This is sort of an interesting thing. Include equals false actually combines the chunk options echo equals false and messages equals false, warning equals false, and results equals hide. And so it actually suppresses everything that's visible in the chunk. So I can just do include equals false in this case. It doesn't hurt to also have echo equals false, but I don't need it. Okay, so I do that, and that hides it. And typically, if I'm working in an actual Markdown document, as many of you I hope will be in the future, I almost always have a chunk up here called, I usually name it setup just to make it clear what it is. And then I typically load all my data, do all my packages, all that kind of stuff. So here's a question. In the MyR Markdown doc, when you create a new Markdown doc, you'll get this default chunk at the top that says like R setup, include equals false, knitter options, $set echo equals true. You don't need that, but it's an example of something you can do. So if I take that line of code that you just had there in chat, like that, this right here is the way you would tell knitter. Knitter is the package that turns our Markdown documents into HTML files and PDF files and stuff. So what this says right here is I would like to set the chunk options for all subsequent chunks to be this, echo equals true. So this sets the default to echo equals true. By default, it already is echo equals true, but you can flip this and say echo equals false. And now by default, every chunk that occurs after this will have echo equals false set to it. So you don't have to keep typing the chunk options. I generally prefer to manually set all my chunk options in each and every chunk. But if you want to set your defaults, you can do it this way. I don't like to show this too much in class because it involves a couple confusing things in here. You might be like, why is there double colons here? What is the significance of the $sign? It's the only time in R you're ever going to see a function accessed using a $sign like this. It's quite strange, but this is a way to set defaults if you want. That makes sense. If that doesn't make sense, let me know. Okay, so with that, we've got this thing set up. something you might do, you don't need to put this in your homework or something, but something I generally like to do anytime I sit down with a new data set of some kind. I like to do either structure, Gapminder, which would show me the sort of the structure of the data set. There's also a dplyr version of structure that's a little bit better for this called Glimpse. Glimpse, you'll notice, has a slightly less bad looking output. It automatically constrains the width of items so it doesn't have line breaks in it. Glimpse lets us take a quick look at our data. It says, for instance, we have 1,704 rows, we have 6 columns, and we have these 6 columns specifically that are, for instance, factors, integer, double, and they take values like this. Glimpse is a good one. I use Glimpse constantly to take a quick look at data frames. It's better than just displaying head of a data frame. So if I do head of a data frame, head Glimpse, head Gapminder. Head Gapminder, I'm going to get something like this, which is actually kind of a nice output. But if you have a lot of columns, it's going to cut them off and you're going to have to browse through them. If I do Glimpse, Glimpse will display lots of columns because it turns them into being kind of a row style view. Okay, so took a quick look at it. Now that we've seen what the data look like and you're glancing at this here, what do you want me to do, or what do we want to do? What kind of things would we like to plot or subset or anything like that? This is up to you.
I have a question. Sorry, I'm not sure if I should raise my hand or.
Just talk.
Okay, yeah. So if we can we can just talk about like where the aesthetic goes in the line of code and how that can help you fashion your plot in different ways.
Sure. Do I have a suggestion for a plot you want to mess with to show that off?
Yeah, let's do like life expectancy over GDP and like from the Gapminder data and like do a geom line and maybe if we can facet wrap by continent.
Yeah, we can give that a go. We'll see what a line plot will look strange if you have things that aren't necessarily ordered nicely, but GDP per cap and life expectancy should generally be working their way in the same direction, so a line plot might work for that. Okay, so if I want to create a plot using the Gapminder data, what do I start with? Anybody?
You got to start with ggplot.
Ggplot. And typically what would be the first thing we put in? So this is actually kind of funny because it just popped up a little tooltip telling me exactly how you normally lay out the arguments for ggplot. So we'd normally put the data set first, as suggested there in chat. The data set in this case, Gapminder. Okay, now I'll show some options here as far as the AES. We already know we want to do, let's say, x equals cap, y equals life expectancy on this plot. I'm just going to show you, it just is going to create sort of a background, a canvas that we can work on here. By doing that, we have GDP per cap here, we have life expectancy here. The aesthetic right here in this ggplot sort of set this canvas for us, but it's the only thing it did. If I wanted to make this is not going to be a very pretty thing, but I could say if I want a geom line here of this, I'm going to get an ugly plot bouncing across all the different observations, and some are way out here, but I'm going to get a geom line through that. Okay, I could have my aesthetic here in the geom line call instead, and I would get exactly the same thing. So what ggplot is doing here is if I have my aesthetic here in the geom line, it applies this aesthetic as far as where things are going to be located only for geom line over here. If I decided to add another aesthetic like geom point for some reason, let's break these into their own lines so you can see what I'm doing. Geom point, it's going to get angry at me. It's going to say geom point requires the following missing aesthetics. It requires X and it requires Y. because it doesn't know where to find these aesthetics because I've put these aesthetics only in geom_line. If, however, I put them up here in the first call, both geom_line and geom_point can access them. Because what happens is any aesthetic you set up here or you map up here in ggplot gets handed down to every subsequent geometry. So one of the reasons you would put your aesthetics up here instead of, say, in geom_line is if you want them to apply to multiple geometries. And it's pretty common to do something like this, where you want lines and lines connecting dots. It's two separate geometries, but we want them to both be going to the same x and y coordinates. So we'd probably put the aesthetic up here. I could equivalently, and this would be annoying to do, I could equivalently do this and get the same result. But what ggplot is doing, if I put it up here, is exactly this. It's just sending those aesthetics to both of them simultaneously. You might be like, well, why wouldn't you always put it in the ggplot call? Because sometimes you're going to feed different aesthetics to different geometries. Here's an example of doing something like that. Let's say I do only in geom_point color equals continent. Okay, now you'll notice geom_point has inherited the AES, the aesthetics for X and Y, but I've specifically set color only for geom_point. My lines remain black because no AES color has been set for them, but the dots are differently colored. Why would you want to do this? I don't know, but you can probably come up with some interesting applications for mixing and matching these aesthetics. So this is sort of why you might have your aesthetics in different parts of your plot. Wherever you put an aesthetic down in like one of these geometries, it will only apply to that one geometry. If you put it up here, it will apply to everything. So if I move color equals continent up here, take it out down here, the lines will be colored differently too. And that's all it'll do. You'll notice it actually broke them into different lines too. There's a separate Africa line, Europe line, Asia line, and so on. Because if you color on a discrete variable in ggplot, it also automatically groups on that one, thus creating different lines for each continent, which aren't very informative because we have way too many observations within these ones, and they're not ordered in any sensible way. We instead, as was suggested, might say, let's facet over continent. This is still going to be a hideous plot, but we're working our way up. I faceted out by continent, so you can now see the correctly colored observations are in their relevant facets. But now what we might want to do is, instead of doing color equals continent, we might not want to mess with that. I'm going to instead say, let's group on individual countries. What this is going to do is it's going to make it so there is one distinct line for each country, even though we're faceted over continents. I'm not going to mess with color equals country yet because it's going to be way too many colors, but okay. Now we have a situation where most things are kind of clustered together. It's hard to see, but each one of these lines, dots connected by lines, is a different country in each one of these continents. It might be pretty hard to break them out into a nice way by country, but we could see what happens if I do that. Do color equals country. Okay. If you've already done this, attempting this homework, you probably know what's going to happen. We're going to see probably mostly a legend. Yes, we're going to see mostly a legend. Because what's going on here is ggplot automatically generates a legend for us based on whatever we say put color on. The problem is there's like 140 countries in this data set. So we end up with a plot that's basically entirely legend. We could then instead say theme legend.position equals, is it none? Is that what it is? Yeah. This just hides the legend. Now every country has a different colored line and dots, so at least we can see there's multiple countries. This is still not a particularly useful or easy to read plot for a variety of reasons, but we're kind of getting closer to something you might actually be able to read off of. That help explain some of those things? Anyone have any questions to build off of this? Something you might do to make it a little bit more readable here would be scale x logarithmic. Put x on a logarithmic scale because the relationship between GDP per capita and life expectancy is going to be log linear. GDP per capita tends to move logarithmically. So this will spread things out a little bit. It's still unreadable, but at least now the curves are a little bit better.
So I was looking at something similar to this, and I really, really wanted to just like segregate the high GDP countries, like a high, medium, low, just like, yeah, and maybe facet wrap by that, and it was like just weird and getting crazy.
Yeah, okay. Well, let's see. First, if we want to separate out high, medium, and low GDP countries, the easiest way to do that is to make a new variable in the data set that's categorical that indicates high, medium, and low GDP countries. I helped somebody with that on chat earlier. So I'm just going to show how to do this because we haven't introduced the tools necessary to know how to do this. The easiest way, in my opinion, is with the case when function in dplyr. Brian will be introducing dplyr stuff on Wednesday's lecture. I'll just go ahead and kind of give you a preview. So what we want to do, right, is we want to take the Gapminder data, which again looks like this. And what we want to do is we want to split GDP per capita into like a high, medium, and low GDP per capita. So to do that, I'm going to create a new variable to do that. You haven't been introduced to the function in dplyr for generating new variables. This function is called mutate. You mutate a new variable. We're just going to call this, I'm going to call it GDP categorical. I'm going to say GDP categorical is going to be the result of running another function. The function I'm going to run is going to be called, actually, you know what the easiest way to do this is? Entile GDP per cap 3. That do the job? Ah, yeah, that'll do the job. Okay, this might not be the most useful way to do it because it's going across the GDP per capita for every year in the data simultaneously and cutting it up into quartiles. You'll have a lot of cases where countries go from being the bottom quartile to the top quartile simply because of time. But what this function does here is say, I would like to get a particular quantile of my data, divide up GDP per capita by quantiles, and return it as a categorical variable. So this says, take all the values of GDP per capita, divide them up into 3 equal bins numerically, and then just tell me which bin they're in. So if I look at my data here with this first country is Afghanistan here, when its GDP per capita is like 779, 820, and so it's in the first bin of GDP per capita categorical. If I browse through my data, you'll see Europe here is in the category 2. Some of these countries, if I keep going down, whatever country this is, if I scroll over here, is Argentina in the 90s, is in the top, what do you call it, tertile, the top tertile of GDP per capita. This is a quick way to create a variable like that. You might instead want to do something like do it so GDP per capita tertiles within a given year, which I think would be a more useful measure. I could say group by year. And now that would be year-wise entiles of GDP per capita. That way it'll appropriately move over time to adjust. And you won't just have it so all the countries in 2007 are in the top one just because of GDP per capita increasing uniformly everywhere. So this is an excellent question. I introduced these operators only a little bit briefly in lecture 2. This is the pipe operator. It's a pipe operator. It's the most commonly used one in the tidyverse. There's actually a base R pipe too that's arriving soon. But anyway, this is the pipe operator. What the pipe operator says is take the thing on its left side and set it as the first argument of the thing on its right side. So I could take this exact statement I wrote here and instead write it like this. Remove Gapminder, put it there. Take this group by thing and put it there. These are equivalent statements. They will produce the same result. The first one is easy to read. The first one says, take the Gapminder data and then group it by year, and then create a new variable called GDP per capita, which is equal to the tertiles of GDP per capita within that year. This down here says, create a new variable using grouped Gapminder data grouped on year to create a variable GDP per capita equal to the tertile of GDP per capita. This is, to me, a little bit harder to read. They do equivalent things. Technically, the bottom one is, actually, in this case, they'll operate at the exact same speed as well. Yeah. That makes sense with that pipe operation?
Yeah, is there like a common mistake that I could be making? Because when I tried to do it, it says cannot find function of the percent greater than percent.
Yeah, it's in the dplyr package by default. Well, dplyr loads it. Technically, it's in the magrittr package. So if you do library tidyverse, you should have it loaded. If you do library dplyr, you should have it loaded. But you need to do one of those two.
Okay, great. Thanks.
Yeah.
Do you think we could maybe try and facet wrap by GDP
Oh, yeah.
tiles?
Okay. So a fun thing about piping stuff around, you can start doing stuff like this. You can actually do all your data manipulation creation of stuff and not even create an object and just send it right into the plot, because the first argument to ggplot is the data. So this says, finish making my data, do all these operations, and then make it the data set I plot with. So I'm just going to plot it straight into ggplot. I'm now going to say, let's look at, sure, I can do GDP per cap life expectancy. That'll make it really clear what's going on. GDP per cap life expectancy plus facet wrap, GDP cat, put that on some line, plus jump point is a sort of an example here. Okay. So by splitting it out like this, let's go ahead and borrow this scale x log 10 here. Make it a little clearer what's going on. Okay. So you can tell your categorization worked because in the first tertile, all the data is hovering over here. In the second tertile, it's all hovering in the center, and in the top one, it's all hovering over here. In other words, these things are non-overlapping data sets because we stratified them on a mutually exclusive sort of categorical variable. Okay. So in this case, we're actually not gaining much by faceting over them because they're sort of occupying different areas of the plot to begin with. You know what we could do? Let's say facet over continent and color equals GDP cap. Okay, and now you can see, for instance, the countries occupying each level of our categorical GDP in Africa, Americas, Asia, and so on. So you can see, for instance, all the countries here are in the top tertile. In Europe, there's actually, there's an observation here that's in the bottom, but most of the time they're kind of up high and so on. All right. This might be a more useful thing to do, fast on comments in that. You'll notice here that it thinks GDP categorical is a continuous variable because I didn't convert it into a categorical variable. If you really wanted it to be a categorical variable, I could take this up here, wrap it in factor. Now it knows it's a categorical variable and will give them colors that are more distant in sort of looking for hue. Question in chat. Doing a line graph with 2 lines, one for each country. However, I cannot get the legend to show up. There's no error in my code, so I'm going to work out a legend with line colors corresponding to the country. Paste your code in chat, and we will modify it to get what you want. Typically, yes, all the code of that graph. Typically what that is you have 2 different geom-line calls, and so it doesn't know how to generate a legend with it because you've essentially just plotted 2 completely different data sets. Typically the solution is to put everything together into a single. Okay, so let me see. that might not be the case what you're doing. Okay, so let's put this up here. Okay, yeah, that's what you've done. Okay, so the reason it doesn't know how to do anything to legend is it doesn't have anything to work with here to produce a legend. So legends get generated by pulling things out of the data in mapped aesthetics. You have it set with color equals red and color equals blue here, sort of manually as a set aesthetic. It's not going to do anything by default and create a legend with that. And so I would assume your data is China and Japan, just all the observations from China and Japan. Typically what I would do for this is instead of setting it up like this, I would say, take my Gapminder data, filter so that the countries we're looking at are China and Japan. This will filter our data down to only be the observations from China and Japan. Okay, now I'd send that into ggplot. Say, take the aesthetic, move it up here. Going to delete that. Color equals country. Okay. Oh, and I want to group on here. Strings, Chuck. What did I mess up here? Yes, X is here, Y is laser. Oh. Now what did I mess up? Why is it going straight up and down? Group. Oh. Well, that will certainly do it. Okay. So what I did here is I said, instead of taking two different data sets to plot on here, I instead generally want to send ggplot a single data frame. ggplot expects you to be working with a single data frame and plotting over. So what I said here is I'm just going to get a data frame that is only the countries China and Japan. I'm then going to make my plot where X is year, Y is life expectancy. It's grouped on country because we're making make a line plot. We want the line to go through all of the points for a given country. I say color equals country here, and then I just leave everything else the way you had it. And now I'm going to have one line for Chinese life expectancy, one line for Japanese life expectancy. They'll automatically have a legend down here indicating which is which. If you want to manually set the colors, you could use scale color manual and take care of that. So I'll get to that question here in chat in a second, but I could say scale color manual, and then I could say values, and I could say, right, the colors you had before were China was red and Japan was blue. Oh, they already have those colors. So I guess I don't have to manually do it. But as an example, I could say China is purple and Japan equals. And now China is purple and Japan is black. Make sense? It's okay if it doesn't. But if it does, that's nice. So yeah, sorry, what is percent in compared to pipe? So this is the thing. This thing right here looks very similar to this thing right here, but they do very different things. So they are still both operators. An operator is just a function which takes an argument on both sides of it. So an argument on the left side and the right side. Pipes are weird because they take usually like a data object on the left and a function on the right as their arguments. It basically passes this into this. Percent in is a logical operator. It's something like equals equals or not equals or greater than or less than. Percent in here, so this statement is exactly equivalent to this statement. Maybe not exactly, but it's basically the same. So this says filter so that country is in either China or Japan. And this says filter down so that country is China or country is Japan. So percent in is a way of saving you from typing lots of or this or this or this statements. If you had a vector here of a lot of things, it'd be really annoying to type this equals this or this equals this or this equals this 500 times. Does that make sense? We'll use it a lot in this class, so you can kind of get a feel for it. Okay, so, and Yusuf says in chat here, can you mind sending that plot code. I think this is this plot code. Okay. So, toyed with some stuff. Okay. Any other questions about any of the things I've already done or new questions? I don't mind going back over these things in substantial detail if you're interested in, if you didn't catch anything, because I know sometimes I talk quickly and I type fast. Just let me know. See if I missed anything.
May I ask the question?
Yeah, go ahead.
What are some, like, I've been trying to think of how we can incorporate like histograms or bar graphs into this. Is there an example that you can show?
Sure. Whole bunch of things I can show you. So, show you an example. So histograms are for histograms are essentially a way of visualizing the distribution of a continuous variable by bucking it into discrete units. So if I take the gap from the data, ggplot, I'm going to say AES x equals GDP per capita, geom histogram. So geom histogram is going to give me, this is a histogram of GDP per capita showing me most GDP per capitas. GDPs per capita are like way down here near zero. I could instead do something like asset wrap continent, or actually, let's show you something cool. Let's go Bassett grid year by continent. And take a second. Okay, so not very readable right now, but what this is showing is a year by, this is count over here. Yeah, this is the count. So this is a year by continent histograms of GDP per capita. It's not the type of thing you'd actually probably do. But you know, this is something you could do. You can kind of see in general, like the histograms for Africa tend to almost always have GDP per capita sort of down here on the left side. Americas tend to be hovering sort of in the like middle over here. Europe moves from being kind of in this region here, shifting upward over time. So you could probably clean this up and make this a lot more readable and useful. But you know, let's take off continent and go up here. Okay. Go back to this. So, you know, histograms. Histograms are a good thing to do and use just to glance at your continuous variables and data sets before you ever do any kind of models or anything like that. You know, let you know if you've got some really funky distribution or something. You don't need things to be normally distributed. That's a residuals thing rather than a variable thing, but it's still good to take a look at them. Yeah. Bar plots are different though. So bar plots are only for discrete or categorical variables. So I say x equals, say, comment, geom bar. This is a bar plot showing me how many observations there are in each one of the continents. So they're country year observations. So different than a histogram, even though they kind of look the same. You can then do something fun with this, actually. Sorry, not colored. And fill year. Oh, because it's a summarizing one. I'd have to do it by column. Yeah, I can't do that here. That's too bad. Oh, if I use geom call, I could do some funky stuff with color and everything. I feel like it should aggregate for me. I wonder if you're up to it.
On the
Aggregation? Yeah, that'll do aggregation. Yeah. What was your question?
On the side that says count, do you mind going over what that variable is?
Oh yeah. Okay. Yeah. Sorry. Sometimes these things just pass through my brain. I'm not even thinking about it. So what a this calculated count over here is ggplot has actually created a new variable and plotted it on the y-axis. What it's done is it's counted how many observations there are of a given continents. So it's counted, for instance, for Africa, there's over 600 country year observations in Africa, because Africa has a lot of countries, right? So this is basically just saying, okay, I'm going to count them up. Technically speaking, what ggplot is actually doing, which is, I don't know if you didn't want to know this, too much information, but what it's actually doing is this. It's taking the Gapminder data, it's running the count function on it by whatever I put on the x-axis, and then plotting it as a bar chart. Yes, so I actually want y equals n, x equals continent. I cannot type it. This is actually, if I take away the group and fill, you'll see that these are the same plot. So this one that I created here with geombar, and this one that I created here manually, that's the same plot. What geombar actually is doing is summarizing your data based on whatever you provide as the x-axis variable, and then plotting the count of that variable. We're going to introduce this count function on Wednesday as part of dplyr, but geombar is a sneaky function. It's not actually plotting the data you give it, it's aggregating the data and then plotting it for you. It's a convenience function. If that's confusing, do it this way. If it's not confusing, excellent for you, and do it this way.
Right, thank you.
For the longest time, I always would forget how to use geombar appropriately, and I would just manually tabulate my data and use geomcall. Nowadays, it just like, it works in my brain, but it took a while.
I was hoping to ask a question about the, I don't even know what to call this exactly, but the factor, it's not a command, but the sort of option, or, so basically I tried to do a set of box plots where I was then sort of coloring the boxes by the category that I wanted to compare. And I was surprised that I had to add this extra little step where I told R that even though I was looking at year, which is numeric, I wanted it to be a factor. And I would love to hear sort of like what that's doing and why it's necessary.
Yeah, okay. So factors are important. So R is a language made for statistical computing, and statisticians, when they're like putting this thing together, realize that often people like to work with categorical data, some kind that looks like categorical data we think of, like names of countries. You can treat year as a factor too. It's sort of like, you can think of years as being something either categorical or numeric, kind of like evenly spaced, but kind of depends what you want to do with it. Anyway, so the idea is they knew we wanted to do those categorical data, but usually you want categorical data to be used in sort of specific ways in operations that you do. So if you run a statistical model, you want these things to have a relation to each other, like one of the levels of one of the categories is a reference category, say like that'll be your reference category in a regression, or you want to be able to order these things in a plot in a particular way other than alphabetical. Factors, the idea of a factor and the factor data type gives you a tool set to be able to set reference levels and the order of levels to them. So as an example in this, if I take, look at the Gapminder data itself, the Gapminder data, right, has country, Afghanistan, continent, Asia. These are factor variables, okay? Well, the thing with factors is, if I say, what's an easy, good one that's already in continents? Okay, so we look at this bizarre, silly string disaster. Here, if we've got a plot like this, you'll see how it's ordered the continents alphabetically. Okay, and you might think to yourself, oh, it makes sense for them to be ordered alphabetically. But if you think about it, why are they ordered alphabetically? The reason they're ordered alphabetically is because they're a factor, and by default, factors are alphabetical, but they need not be alphabetical. I can mess with this. I can say, take the Gapminder data, mutate continent to be equal to FCT relevel. I'm going to say continent, and I'm going to put put Asia first. God, man, I cannot type. Okay, let's put Asia first. Okay, so they're no longer in alphabetical order. What I've essentially said here is I want to modify the continent variable. So its first level is now Asia, and it's grabbed Asia and stuck it over here. This should make it immediately apparent that your plots are not being organized alphabetically. They're being organized by the levels of factors. You might be like, well, how do I know the levels of a factor? If I go like this, I can get the levels of a factor using the levels function on it. So what I just did there is a fancy way of doing Gapminder continent. That in the Gapminder data set, the continent variable is a factor. Factors have levels. By default, they're alphabetical like they're in this data set. But if you modified them, they have these different levels. The levels of the factor, which you can modify, control the order things show in your plots and stuff like that. And the first level here will be the reference level in a regression model. So factors are useful. They're sort of powerful for doing things like modifying how our plots work, but they also drive us insane sometimes because you forget about things like, well, how do I organize these things in the levels I want? Your experience with a year variable is essentially that thing. Yeah. So basically you need to make it be a factor. So for your example here, you essentially had big Gapminder, Gapminder, mutate year equals factor year. X equals year, y equals GDP per capita, supply. You did something probably like this, probably not GDP per capita, but life expectancy probably be a better one. Yeah, something like that. By converting it to a factor, it's going to have the nice sort of categorical levels and labels down here. Usually box plots, I don't know how well it's going to like it if I don't factor it. It should still work.
Yeah, that was the
Okay.
problem I got, is it just collapsed it all into.
Yeah, because
Yeah.
it thinks it's a continuous variable.
That's interesting.
Yeah, I wonder if it would work with as.integer. Nope. Okay. Yeah, wants to be a factor. Yeah, just because it's expecting categorical data. A lot of things in R will sort of enforce those sorts of things, being like, well, if you're going to be using something that must be categorical, let's make you turn it into a categorical variable before you do it. And that's basically what it's doing.
Cool, thank you.
Yeah. Question chat. Do our graphs have to be very different? For example, can I have two graphs with different y variables, but essentially both line graphs comparing two countries? Yeah, go ahead, you do you. I just want you to have a few plots. I'm not picky about what they're about or anything, as long as you fulfill the basic requirements. It would be great if you experiment just for your own benefit, but it doesn't matter to us. These are exercises that are just, I try and force you to do a minimal amount to explore like useful functionality, but otherwise do whatever you feel like doing.
So I really like this ggplot situation for like just seeing what the data is about and like getting an idea of like what is in this data. Like I'm a visual kind of person. And so like I was trying to so I had like all the countries, all the continents, all the GDPs, all the life expectancies, and then I was trying to like narrow it down. I was like, okay, I want the top, top third in life expectancy, and then I was just like trying to. So like, are there tips for that? Like, okay, well, I want to take out like the bottom third, or I want to keep the. You know what I mean? Just so I know, like, okay, these are the countries that have like, in this data that have like, these like some of these characteristics are the same in these countries, in these continents.
Yeah. So give me a specific example, like give me one exact example of something you want to do, and I'll see what I can whip out.
Yeah, so I was just trying to break out all the countries. I was trying to essentially get like all rich Western democracies like on a graph without like just plugging in their names. Does that make sense?
Yeah, that makes sense. Okay. Okay. So what I want to do is essentially, so you want rich Western democracies. So,
Or just like countries with like so I tried to run like the mean. I was like, okay, Gapminder mean GDP, and I was like, okay, so I just want all the countries that have higher than the average like GDP per capita,
Higher than
and
average
take everything
GDP.
else out.
okay. Oh, well, yeah, I mean, that's easy. With that, I'd probably just do filter, and I would say something like filter GDP per capita is greater than, say, median GDP per capita. You might do that within years or something like that. So by within years, within each particular year, give me all of the countries that are above the median. You're going to end up with, roughly, it's going to basically have the number of rows you have. So I went from like 1,704 to 852. It exactly halved it because the median's the 50% point. These are all the high GDP per capita countries, or higher half by year. Does that make sense?
Yeah, absolutely. And then I was also trying to, and then maybe, right, facet wrap it, like put it on a graph with a facet wrap per like I guess because this data has continents, I guess that would probably be the best facet wrap.
What do you want on the aesthetics?
Let's do. I'm into life expectancy and GDP per cap, but whatever. I mean,
Yeah, if I could, I can get anything because I didn't do any geometries. Point. And I get something like that. And like I always say before, I tend to like to, your mic is still open, by the way. Looks like 10, give me some log axis, something like that. Yeah, kind of get a cloud. Could do something fun like, smooth, yes. Some smooth lines to the middle of them continents.
so okay. Sorry. Let me know if I'm asking too. I'll just take a break here and let other people ask.
Oh, it's fine. If nobody else has anything, you're good to go. But yeah, does anybody else have anything? Also perfectly happy with very like smaller questions, earlier questions, things that you think might be too simple. They're not. Just let me know. Doesn't have to specifically be ggplot or plotting. It's even a common question people tend to have on screen right now. People see something that doesn't make sense to them.
So I guess at like this point here, I would try to like narrow the countries on the graph even further.
Mhm.
So I would group by country so I know like, well, it's like yeah. So how can we get the if you group by country, would you get the legend that tells you like what countries are here?
It's basically never going to be a good way to put country on a plot like this because there's going to be too many of them. So I would generally avoid when you have these many, for instance, this many points, you probably don't want to attempt to label or subdivide the individual countries like individual countries. You're just never going to be able to make any sense of it because there's, there's probably, 70 of them or something visible right here. So a legend will be useless. Text will be useless. It's just too much to display.
Okay. Yeah, because I mean, I'm looking at this and it doesn't like tell me like what I want to know, which is like, um, you know, what countries are here, and right, it doesn't let me like look at the. It doesn't give me a visual representation of what the data, what's in the Gapminder data, which is kind of my goal when I was like doing the homework. Was like I was like I just want to see like
Mhm.
what's in here and like how you can mix it up and how things like relate, I guess.
Well, the thing is that so not everything not everything is a sensible question to do in with certain types of visualizations. If you want to see like every country at once, you're not going to be doing that in something like a scatter plot. It's just like it's probably not a meaningful way to do it. So it kind of depends on like specifically if you can verbalize exactly like the sort of thing you want to be like, I want to see this thing. There's a way to display it, but the real question is what is the appropriate way to display it. So if you've got a particular like a verbal question that you can state, there's going to be a way to see it. It won't necessarily be a visual thing that would represent it best. Typically it is, but not always. If you want to see every country simultaneously in some way, it might not necessarily be, but it depends what you want to do. Do you have a specific thing, for instance?
Yeah, so that's I guess that's my problem is like I don't specifically know. Like I don't know the Gapminder data
Mhm.
well enough to know like what's in there. And so like really I'm just trying to visually see it. Um, and not like every country, but like how would you narrow that, like how would you narrow that further? Like we did midi like we eliminated all the lower half median GDP
Mhm.
countries. Like is there like another like common thing that people do when they're like trying to just compare like life expectancy in rich countries?
If you want to know different for life expectancy, so okay, so this is sort of a so if you want to know about life expectancy and GDP, it kind of depends, sort of. I mean, you're going to get a pretty clear relationship between life expectancy and GDP. I would normally do something. So keep in mind that if you're talking about, okay, I want to know the relationship between life expectancy and GDP per capita. You specifically are sort of stating something that is a relationship not uniquely defined for a single country. That is something that is a relationship that's sort of a sample or population type relationship. The relationship of GDP capita population and life expectancy is something that's defined only for a group, right? Multiple observations. So if you're doing something like that, I might say, um, let's look at, uh, let's split it out by, why don't we split it out by year and see how it changes over time, for instance. So you might say something like per capita, y equals life expectancy. I'm going to say here, yeah, that's it. Best on year. I'm going to uh, point, and then I'm going to smooth. Let's make this. Okay. So, oh yeah, and I'll put a log axis on there. Let's break this into multiple lines for readability. Okay, so what I've done here is this is sort of me looking at what is the relationship between GDP per capita and life expectancy over time. So I essentially am starting with 1952 and going to 2007, and you can kind of see that on average, life expectancies are moving upward over time. You can see that the top life expectancies over here were hovering around 70, whereas now the top life expectancies are hovering around in over 80. The bottom end ones are actually staying, they're going up quite a bit generally too. So we see here that all of them are basically over 40. We're here a large number are below 40. The relationship though sort of always looks more or less the same. You can kind of ignore the smooth line here because this is, massive GDP capita country. There's only one out here in all these observations. So the line's typically just a line moving pretty upward. It looks like the relationship is overall pretty similar. It's flattening a little bit over time. But yeah, this is sort of like an example of a plot that might be useful or interesting. You see that generally there's sort of a stable positive relationship in GDP per capita over time. But maybe it's flattening a little bit and the whole thing seems to be going up.
Okay, again, like if I'm talking too much, please
No, you're good.
let me know. But okay, so maybe like in this graph, then we can color individual countries. So like right now, I just want to see like, okay, where did the U.S. start out in 1952, and where did they end up in 2007? Like if we color the countries, what would that look like? Just one country.
Yeah, if you want to color one country, you can absolutely do that. So this is actually kind of a goofy way to do this, but it'll probably work. Color equals So this is one of those things you typically don't want to do, but you absolutely can. You don't necessarily have to give a variable up here in your like AES. You can literally put a logical statement up here and it will test it and return either a true or a false, and you're going to get it. You can see in this particular plot, the United States tends to be always hovering at about the same location, quite far up the scale, but it's basically all up there.
This is super cool. Okay, now I'm getting excited. Okay, now can we also color in another country like Japan?
Yeah, you could. It gets to be a little awkward here now, so I'm just going to go ahead and create a variable. I'm going to say mutate all country is going to be equal to, let's go case when if country is equal to United States, US if country to Japan, if Japan, otherwise other country will work. Other here, color equals color country. Now you've got like a dot for Japan, a dot for the United States. They're kind of a little bit hard to see. You might do something like mess with transparency or something like that.
Yeah, that's what I was thinking. Maybe we can make the others a little transparent.
I can go like this. Alpha equals color country, scale alpha.
Also, when you do mutate, it's just like your personal preference, because I'll just create a variable with like, my default is to, because I've been working in Stata, is to create a variable with like the countries that I want to see.
So I'm not sure you.
Because mutate and in are sort of like, what's the difference between mutate and like creating like a variable with like,
I mean, like assigning like that, you're saying, or assigning that way, or this is
well,
just
yeah, because well, no, never mind. Sorry, forget that last one.
Okay. So US is going to be equal to which way does it map? I think it maps that way. US is 1, then equals 1. 0.3. What will that do? Let's see what happens. Yeah, okay. So I made those other ones partially transparent. You could probably take it down to 0.2. And so I can actually take this color out of here. Oh yeah, I want that color to be and I'll leave that on group here. Yeah, it could do something like that. You can kind of see the United States moving its way up, Japan always being, or the US here, Japan moving its way up. It's not ideal, but Yeah, you get in there. A lot of things you have to tweak on this to make it not look like garbage.
Yeah, but you can definitely see like in 52, like there's a huge gap, and then by 2007, it's
Yep.
like, yeah. So that's pretty much what all
Yeah.
like. Could you, would you mind putting the code in the chat so I can mess with it?
Yeah, sure.
Thanks, Chuck.
Yeah, a lot of things you want to mess with on this to make it, a little bit better and more useful. But yeah, you can squeeze a lot out of these things, and typically a lot of things that people try to solve in the plots, like trying to figure out how to like divide data and stuff, actually just needs to be done ahead of time. So like in the data, you might create new variables and things like that, and use those to do operations here. Yeah. Spaces out to make that clear. Yeah, fun stuff.
Hold up. Did you just move GDP per cap and life expectancy at the same time?
Yeah.
With your tabs? How did you do that?
So Control Alt and then arrow keys up and down will increase your cursor. You can also hold down Alt like this and do block selection. Block selection is really useful like that, so you can grab like just the stuff here, but you can use it selected there to like delete everything, space out and stuff.
Okay. Huh.
Yeah, incredibly handy. Yeah, and of course, if you do that, right, so you can, if you're typing like lots of equals and stuff, since it'll do all of them simultaneously, it's pretty handy for like typing out certain types of statements and things, copying and pasting, doing checks. I do it a lot for like variables in like big long select commands when I start opening a data set or something. Yeah, pretty handy.
So I'm just trying to adjust the scale here, because it looks like maybe like the minimum value is like on the y-axis is like 50.
There's some all the way down here in the, what is that? That's maybe just over 30.
Yeah, well, so yeah, but so those are like the ones that we're don't really care about, I guess, as much. Maybe we should just take them out then.
Yeah, I mean, if you basically, so if what you want is to restrict the data you're looking at, yes, but the way to do that would typically be to filter it out ahead of time. So don't mess with them in the plot, but filter out, make the explicit case that you're like, okay, I don't want to include any values where, life expectancy is maybe cut it off, probably not 40 softly. So say nothing, make sure they're all at least 35. All right, you could do that, but that's an explicit, like I'm dropping cases that are that. So you know you're doing it, right? So how many would I lose? So that would cut out, what was that, 30 some observations, right? 33 observations would be dropped if I restrict life expectancy to there. But doing that will bring the bottom of the scale up a little bit. But keep in mind, usually you don't want to do that. It's kind of like this thing where sometimes if you're being taught by people who shouldn't be teaching methods, they'll talk about things like removing outliers and things like that. That's not a thing you should do usually, because you're just dropping data that's real data. if an outlier is the result of bad data collection, that's when you drop it. Normally, otherwise, you don't. And in this case, that's a legit observation. Like that observation down there when the life expectancy is hella low like that, that just happens to be occurring during a massive genocide. It's a correct life expectancy. It's very low. I wouldn't want to remove it from my data for almost any real purpose. It might mess up my axes, but I would say preserving reality is somewhat more valuable than a pretty axis. So, yeah.
That's a good point. But I do really only care about like 2 countries.
Oh, well, then you don't look at those 2 countries. I mean, this is, it depends what you want to do. But keep in
Yeah.
mind, you're doing that. Like, that's a choice, and so the way to do that typically would be to do the filtering earlier. You filter and say, these are the data I want to go into the data set. And if you like just constrained the axis, so that was once we're done there, it would literally just be dropping. By constraining the axis, it would just filter out the data that no longer fit on it. So it's the same result. You might as well just manually do the filtering.
So it's filter country equals
Well,
Japan and yeah.
Oh yeah, if you only want to look at Japan and the United States, then you don't need any of this shit right here. You can instead just say let's go filter.
But I did want to keep the smooth, the regression line here. For the whole world,
Oh,
right?
so you only want the points to show Japan and United States, but you want the lines to be there.
Yeah, yeah. So cuz there is a world.
Yeah.
Yeah. I thought that might be interesting and cool to look at. Oh, yeah. Yeah.
See, I cheated. I didn't drop anything at all. I just made it so that they're 100% transparent. Alpha equals 0 is 100% transparent. They become invisible. They're still there. In fact, it's even drawing them, but they're just not shown. That way it can still nicely draw the curves. Though I probably wouldn't use curves like this if I was not going to show the dots, because it's kind of weird how they curve off at the top here in this meaningless way. I'd probably change my smooth to a strict linear model or something like that. That's a little bit better of a projection when the data aren't being displayed.
All right, so pop quiz for the class. When did Japan exceed the US in life expectancy?
Yeah, it jumps above. That's quite the acceleration right there. And going from here to there, that's such a rapid sort of trajectory. The United States is moving up at a pretty good pace, but not nearly as fast as post-war Japan.
Yeah, they are killing it when it comes to life expectancy. No pun.
I think last check, I think Spain is ahead of them at the moment, but I'm not 100% on that still. Was in 2020, I think.
I'd be careful with that interpretation, because usually when something is holding things low, you tend to have a faster rate. So for example, if you are born with a low birth weight, you grow more than normal weight children, but that's just because you started at low birth weight. You don't end up actually having a higher birth weight or a higher weight at any given age.
What does that apply to?
Well, in this case, it's like you're saying Japan's rate is increasing a lot faster, but they're also recovering from, a major.
But
crisis.
it is.
It's very impressive, absolutely.
Yeah, but it's unambiguously correct to say that the rate is definitely faster, and at this it's the rate is moving faster, but it's naturally rates tend to be operate in a certain type of logarithmic form where naturally they're always going to move faster. It's an inverse logarithmic action where they're always going to be moving faster at the lower end than the top end. That's a physical property. And
Yeah, it is interesting to me to think that they had this massive they caught up fairly quickly and then exceeded past the U.S. like after
Yeah.
1962,
But-
right? Like,
But it's also starting at a bad point for them, which is kind of what I imagine the other point was, that looking at them in 1952 is not the, like, because if you'd seen what they looked like in, like, if you looked at the United States next to Japan in the 30s, you know, it would be sort of a different image you would cast, because their sort of life expectancy modified in a particular way following the war, much the same way that, like, you know, if you follow like Russian life expectancy in the 20s, 30s, 40s, 50s, you'd be like, man, their rates really picking up in some of these places. Yeah, because like, you know, millions of people, their population died in World War II, and so their life expectancy dropped a little bit. So it's like, what is your point of reference here?
well, we're also below this line, right? This line is this blue line. This is the smooth line. This is our point of reference too, right? Like the U.S. drops below it at 19. Kind of like 82, right? The U.S. kind of goes. The point of reference is the what is this line, Chuck? The blue.
It's just
line?
a regression line. So it's essentially
For the world.
Yeah, it's for within each particular year. It's the across every country in the data set. It's the sort of the conditional mean, assuming a linear relationship.
So we're below the.
Yeah.
I guess we're below average then.
Yeah, because every other high GDP country developed a welfare state, and so you know you're going to be right. You would expect that all things equal, we have a very high GDP. So you know it's on average, most people's life expectancy is substantially lower than ours, but you know naturally we're going to be below all the other high GDP countries, which you know don't have these things sinking our life expectancy down. You know, because we have the distribution of life expectancy in the United States is. The overall life expectancy is lower because fundamentally our distribution is wider. We have a higher variance across like different subpopulations of life expectancy than most of those other countries do, because poor people aren't just straight fucked in most of these European countries. So, you know, it's going to be a little bit, if you have more variance, it drags the line down.
Yeah, for sure. We have a lot of poor people and not a lot of safety net.
Yeah. It's actually not even that we have more percentage-wise poor people than they do. We just don't have a lot of safety net. You know, it's like when you see a country like Spain just murdering us in life expectancy, you're like, well, what's the reason for that? It's like, oh, you know, a functioning like system of government.
Very low bar. Yeah, for sure. Can we change the color? Just because, okay, because it looks weird to have the U.S. or the line both in blue, right?
Oh yeah, I mean you can. So we just make the line. I'm going to take the GM smooth. I'm going to move it here, and then I'm going to make it black line. Put the points on top of it. Something like that. Make it a little easier to see. The annoying thing with the legend is it's showing the here I'm gonna hide as a guide. Remember how to hide. I want to hide this from the legend. It's show legend. Okay. Binary. Okay. It's kind of dumb. It shows other there, but it's the price we pay for our shenanigans. Okay. It's a thing. I'm sure there's a way to hide other from this legend if you wanted to, but I can't think off the top of my head the best way to do that.
Yeah, I tried other and like just a period, but that did not work at all.
Technically speaking, the way you would want to do it if you didn't want to just do this would be to feed a different data set to point that you do from GM Smooth. So yeah, so you could do something like filter tree percent in United States And then down here, say, that anymore. So we don't need any of that anymore at all. Let's just go. Don't need that. Doesn't have to exist at all.
Yeah,
okay.
you operate at warp speed compared. Like I find it hard to track exactly what's going on.
Oh yeah.
But I'm trying.
Yeah, no, I mean, if I could slow down, but in this case, I was like, I wasn't sure if the thing I was going to do would work, and then it occurred to me as I was doing it that it would absolutely work. So what I instead did is I'm now plotting two different data sets on here. Okay. So now I'm saying, okay, we're going to filter down to just United States and Japan. We're going to use that for the base of the plot. Basically, we're faceted out by year stuff, but then the smooth line is actually using the entire Gapminder data set grouped on year. Yeah, so this is plotting two different data sets. I'm using one to draw the line, and I'm using the other original data set to display the points. So you can mix and match. This is a good example of when you should use two data sets because it's the easiest way to do this. Kind of gets us the same thing we had with the alpha equals 0, but this is the correct way, whereas that was just sort of a quick way to do it using the existing code. I feel like I should make some nice breaks or labels on this scale, X log 10. It's a nice way to do that. It's a real clean way.
Well, could you drop what you have in there now, and then I can follow you as we kind of like do the labels.
Oh, like drop it in there. Oh yeah, I'm just trying to pick up off the top of my head what's the easiest way to do that. But I feel like honestly, probably just manually set the breaks equals. It's kind of like, what would you want? Breaks equals scales pre-breaks. Maybe that'll do the job. Want non-numerical, you need to do it. Okay. How do I want? No, that doesn't work. Pretty breaks doesn't like logarithmic scales. No idea what would be the good way to pass that dynamically. Because what I want to do is get good uniform logarithmic breaks without setting up manually. Setting things manually is stupid. Yeah, okay. Maybe it'd be better to say scale X continuous, and then say equals log 10. Now, okay, that's just going to be the exact same result. Doesn't automatically. I mean, it's just because they're in scientific notation, which is super lame, and I'd rather convert them over. That's the nicest way to make that label. Oh, I guess I could do it that way.
So do we still have to keep it in log for since we removed like?
I mean, this is exactly the same thing. Doing transformation log 10 is exactly the same as scale X log 10.
Okay.
These are equivalent. Same result. I was just trying to think of a nice way to make this, but you know, it's kind of a mess. But I guess I could theme this dot text dot x equals text 35. Probably need to justify that. Yeah, just equals 1. Yeah. Okay. So, yeah, gussied up a little bit.
Yeah, I think this is like pretty dope.
Yeah, it's all right. Yeah, fun stuff. Good things to mess with. Oop, okay. Questions. Yep. Anything else you want to take a look at? I think most people are out by now, so
Yeah, I think I'm gonna head out. I'm just gonna try to load in some of this. This is it the ANIS data or this
ANES. Yeah.
ANES?
ANES.
Thanks. ANES, yeah.
Not
I'm gonna
working with
try
it
to-
might be anus, but it's now it's the ANES.
Yeah, I didn't know. Yeah, I might load it in and try to see. Like, I'm reading Isabel Wilkerson's book, and I'm just interested to know like the see if I can replicate some of the things she talks about in the about the election, just for
Yeah.
fun, you know.
Yeah, no problem with that. Yeah, I haven't worked with the ANES myself, so don't know much about it.
Okay. Any tips? Try or just like don't do it.
I've never looked at the data set. It's not unrelated to my field, so I don't know anything about it. Yeah, never worked with it. Probably not too bad though. I mean, it's just probably it's a clean social survey data set. It's probably not going to be too bad.
Yeah, and all. Yeah, it looked like a fancy schmancy website too. So that'll.
Yeah, they got money.
Yeah, right.
Yeah, well,
Okay.
good luck with it.
Yeah. Well, thanks. Looking forward to making variables later this week.
Yeah, sounds good.
Thanks.
All right.